Welcome, everyone. Now we come to the next topic that is discussed very emotionally internal to the company as well. The Siemens One Software Engineering System. Welcome, Greg and Igor.
Thanks, everybody. My name is greghaynes. I'm a software engineer focused on CNOE and Siemens One Software Engineering System. I've spent most of my career working on various open source cloud and developer platform technologies. Igor, would you like to introduce yourself?
Yes, so hi, my name is Igor Milovanovic. I've been working at Siemens since almost 20 years in the different roles. Most recent, I was building the internal developer portal and also the external developer portal of Siemens.
Thanks. So we're here to talk to you today about CNOE and also Siemens One Software Engineering System. CNOE is an open source project, like I said, that we're involved in, and then Siemens One Software Engineering System is our implementation of what's called a CNOE reference stack, and we'll go into a little bit more detail about that later. But first, what is Siemens One Software Engineering System? So in short, it's an internal developer platform with the primary goal of reducing developer toil, or said differently, increasing developer productivity. And why is this important? As our software gets increasingly more complex and has to achieve larger scale, there's a lot more costs that our developers have to pay in order to meet both non-functional requirements or our customers' needs. This comes in the form of security, reliability, performance, and all requirements. There's also very complex cases like regionalization, where you might need to perform a globally distributed deployment of an application. And when you look at this from our whole company's point of view, it's pretty unreasonable to ask every software team to face these challenges on their own and solve these problems themselves. Not only is it inefficient, the end result is not what we're looking for. And most of all, we miss the opportunity for collaboration among these teams. And it makes it challenging for them to get the benefits of the best-in-breed technologies or the best practices that they could have gained from one another. So tackling this is their primary goal of OSS. It may seem challenging, especially when you consider how deep and complex some of these issues are and just how many there are to tackle, but fortunately, we're not alone. And this is a challenge faced by many organizations, and that was the genesis of CNOE. A little bit over 3 years ago, a handful of us got together from different organizations and started discussing how we were facing some very similar challenges, solving these problems and building these internal developer platforms using standard open source technologies. One challenge faced in this ecosystem is just the amount of complexity. There's a lot of technologies that are difficult to interoperate, and they have varying levels of adoption, maturity, and reliability, as well as it's unclear to what extent they can interoperate with one another. And so when facing these challenges, we were all talking about how this industry was changing a lot, and we were starting to leverage some of the same technologies, but we were concerned with the risks associated with adopting more, or even what decisions to make next in adopting these technologies. Fortunately, we all banded together and we started to see a lot of common patterns and practices, and we were able to make a lot of progress about what we wanted to do and how we could de-risk these choices about what technologies to adopt. One of the main patterns we saw was sort of a set of foundational technologies that we were all starting to leverage and served as the base for which we could begin to build our developer platforms and adopt yet more technologies that could interoperate with one another. This starts with Kubernetes, which most folks think of as just a container runtime, but all of us were starting to leverage it as more of a declarative state management system and a declarative control plane. Building upon this is Argo CD, which is a standard tool that we were all beginning to leverage it to do change management into this control plane technology. And there's also Backstage, which has seen explosive growth in becoming a developer portal used by all of these teams. What's interesting about Backstage, too, is it's actually more of a framework. And it's interesting about all these technologies. They're more frameworks than solutions. And so one of the challenges we were facing was not only how could we adopt and leverage these technologies, but how could we integrate them into a solution that we give to our developers, and then build on top of them to meet our individual needs. So using this foundation, we began to create this thing called reference implementations. These took a couple different forms. One of them was this tool we made called IDP Builder, which allowed us to create local environments of these stacks, so building on that foundation and then adding additional technologies on top. But what that enabled us to do is to perform local validation and also give our developers, designers, and PMs easy access to these stacks or these reference internal developer platforms. Also here you see some diagrams of some more complex versions of that. The one on the left here is a cloud version. You can see just how many technologies involved, how they interdepend on one another. This is one of the main challenges we face is, okay, there's a lot of technologies in the space. How do they actually integrate and which ones should we pick? On the right here, you see a Backstage UI. And this is the end result, is that with these reference implementations, there's easy ways for our developers or anyone who wants to give these technologies a try to spin up these stacks and get an interface like this, where you can go and you can visit Backstage, get a UI to create an application, or perform a deployment using some cloud resources, et cetera. But what's underneath that is a lot of complexity that's shielded from both you, the person experimenting, and also the person having to interact with this platform. And with that, I'll hand it over to Igor to talk a little bit more about how we're leveraging these technologies.
Thank you. So when we talk about CNOE and how this works together with the stuff which we actually already building, I want to give you maybe an overview of how what Siemens was doing until now, and how we apply the CNOE principles in what we were building already. So as most of you know by now, is we have the Siemens Foundational Services. The Siemens Foundational Services are a set of services which are there to provide the users with the ways of quickly build modern software solutions, be it as a SAS solutions on the cloud or building hybrid solutions on the edge. And when you think about it, where the CNOE technologies are actually mostly applying to, we will see that this is actually happening mostly in our Pillar 0. This is the development and runtime infrastructure, and also the developer experience. So this is where we are collaborating with our, this is where we are also collaborating with CNOE, other CNOE members, exchanging experiences, but also using what we were already building and what we already had, and providing this to our users. So we just saw the example of how it looks like in the Backstage to create a simple Kubernetes deployment. Now I'm going to show you an example what we are about to release. So this is not done yet, but you can already see an example on the code.siemens.com how to do this if you take a look at the link I'll provide. But for example, this is the rollout. This is how the rollout using foundational services is actually going to look like. So let's assume that we have a user who wants to get some basic infrastructure on a shared cluster somewhere in the world. So what we're going to do is we're going to have a template in the internal developer portal, or in the internal or what we are calling now Autobahn portal, and we'll have that user pick a continent. Then in that continent, they can then choose the region. For example, they can pick North America, then pick US East. And then they can also pick a provider. In some continents we have, for example, infrastructure which runs on AWS. In some continents we have it on Azure, and so on. So you can pick and choose what you want. And with that setup, we would roll out then for you the complete GitHub group, plus the infrastructure as a code, which is necessary to, and also a demo app, which is using the foundational services, which is actually being deployed into the Kubernetes cluster, into the shared Kubernetes cluster, where we just created resources for you. So what would happen is we would automatically provision for you infrastructure as a code. So we would create a GitLab group, we would create a repository, we would create a CI/CD pipeline for you, and this would then provision for you a Rancher access, where you can log in with your normal Siemens login using the Enter ID, and you can manage your resources in the Kubernetes cluster from there. You would get access to the shared Kubernetes cluster. By default, we would give you 2 namespaces. You could always configure more. You would get Argo CD for GitHubs, and you would get Habu container registry where you can store your images. And what we would also do in the CI/CD pipeline, we will synchronize the roles and permissions which we have in the GitLab group with your actual access rights which you have on the Kubernetes cluster, which means that if somebody is a maintainer on the GitLab group, they would get maintainer access rights on the Kubernetes cluster as well, and so on. So this stuff would be automatically synchronized between the GitLab group and the rights management component, which in our case is Keycloak. A Keycloak is also on the reference architecture implementation. So this is an example which you can take a look. This is under the code of Siemens.com to-do product. This is not a template. This is a target state of a template. So this is how it would look like. Essentially, there would be a repository. The repository would be then kick off the CI/CD pipeline, and this would generate for you all of these resources, and then it would create a release for you with infrastructure MD file, which describes everything which you just created, so that you can just go and access these files, and we will also generate a backstage catalog entry for you. So if you take a look how this looks like, so this is then the CI/CD pipeline which does actually all of that for you. So we would create from the infrastructure as a code YAML files. We are using Sorcery tool, which is our internally developed tool for provisioning of resources. We would describe what in the repository what you want to have, and then that will get rolled out. And in the release step, you would get then the information about it. So this is the information which gets created by the CI/CD pipeline. So you get a markdown file with all the URLs you need to access the cluster. And because I just said that the GitLab rights are getting synchronized automatically with access rights on the Kubernetes cluster, you would just be able to log in, download your kubectl configuration, and start using your Kubernetes cluster or your Kubernetes namespace in the shared cluster. What we also do is we generate for you a catalog entry in the backstage. So this is something which we can do out of the box for you. But please remember, this is all in your repository, which means that this is the default which we think it is usable. So what we will do, we will generate a system for you which is called infrastructure, and that system which is called infrastructure would get the resources which we are using. However, if you want to change this, if you want to adapt it, and so on, everything is in that repository, so it can be changed, it can be adapted, and so on. But then you also have to change the code generation part, which is doing that in the repository.
And then just in conclusion, so all this tooling that we've demonstrated here is highly accessible and available. This CNOE project is an open source project, like I said, so feel free to check it out. And there's also a lot of tools on there, and documentation and tools you all can use to discover where we're headed with our internal developer platform. I would highly recommend checking this out. And furthermore, what we're here to do with OSS is to build the developer toolchain for all of Siemens. And that's not just on us as any one individual org. That's really on all of us here at Siemens to make that developer toolchain. So my message to you is that we're doing this in a highly accessible and open way, and I hope everyone else will participate and join us. So, thank you. Questions?
There's one question from the chat. Igor, great stuff. Ever consider using vCluster of namespaces? Has a lot of advantages instead of namespaces.
Yes. So this is the current state. So this is what we could do with the current state of the implementation of the compute engine which we have. However, vCluster is actually probably something which we should consider in the future.
Just to plug some of the CNOE upstream stuff one more time, there's some really neat vCluster stuff in CNOE that we use to simulate multiple environment promotions. So we found it valuable there as well.
Thanks for the talk. May sound like a strange question, but we are in culture, we are developing 15-year-old systems that are absolutely not connected to the cloud, but management assumes that the one Siemens engineering system will help us in the future. So people will retire, we will have fewer people to work on our products. Can I hope for any help for my kind of products too, like Windows software, UIs, small embedded devices?
Yeah, absolutely. It's hard to answer like that question entirely in this short amount of time, but just like the way to frame it is, if you look at the way the SDLC, if you break down the SDLC, where far left we're design, planning, and then the right we're talking about deployment and release, there's different levels of adoption that we're going to see across the company in those different phases. So like far left, we can build stuff that applies probably more broadly. And far right, when you talk cloud and SaaS, yes, it's probably going to be more targeted. So I'll have to say it's going to vary, and I know it's complex, but there will be absolutely, those are use cases that we aim to serve.
Perfect. Thanks a lot, Igor and Greg.
Thank you.